Now, when the recording is on, let me introduce you to Walter Riviera. Sorry, I mispronounced it, and I apologize for that. But I looked at your LinkedIn profile. You are a TED speaker. You're AI professional. You're a data scientist. You worked at Intel for 6+ years, and you're passionate about data science all the way from hands-on and all the way to the infrastructure. So amazing profile, and I'm looking forward to hearing from you how you work with SAS to optimize the hardware. Walter, over to you.
Absolutely. Well, thanks for the introduction, and apologize for joining late because of the link, but I'm glad to be here. Just a quick check before I kick off. How much time do I have to stay compliant with the agenda?
As long as you finish by 1 o'clock is fine.
Okay, no, that's fine. No, we're definitely going to stay in there. Another premise, apologize for the red mark, but I had a funny accident, nothing serious, but this is the result of a barbecue that didn't actually work out smoothly as I would expect it to be. With that said, I might have somebody knocking at the door because this morning it's also about a parcel delivery being delayed. So apologize in advance if I'll have to, but I'll do my best to stick with the presentation and go through all the content. It's not that much, and hopefully you will appreciate that. If you have any question, feel free to shoot as I go through the slides. With that said, can you see my screen?
Yep, I can see the screen.
Okay. All right, so as Nevlev said, let's see how we can, how does it work with SAS and Intel? It's long-standing collaboration for more than 20+ years. It's really about helping customers to modernize their analytics infrastructure, either in cloud, and operationalize the capability throughout the whole organization. As I said, we've been working together for many years, but we lastly got even closer for some of the latest and greatest from SAS analytics platform, and to ensure that SAS software would take full advantage of the Intel hardware, and we would help each other to shine. How does that work? Well, in the modernization effort, the cloud native SAS, I'm talking about the VIA platform, is optimized to work and give the best performance on Intel processing capabilities. That includes a lot of steps. It's not that trivial, but hopefully after this presentation, we'll be able to appreciate a little bit more what those optimization consist of. We're glad to say that the effort has been redoubled with SAS migrating from SAS 9 to SAS VIA, and also the ecosystem with partners, with system integrators. It's all prepared to take on this new journey. This is a slide to recall about SAS VIA, but I think there is a better way to show that again, which is by doing this. Something I really enjoy and something I really like. That screenshot comes from an animation which is down here, which basically self-describe the superpower of VIA. So it really comes to the MLOps side of the challenge. And hopefully you will be able to appreciate even more the efforts from both companies, because the level of abstractions and simplification that this platform provides to the end user is just impressive. You can explore and visualize data. You can discover information asset. If you want to deep dive into what data has to tell you, you can manage them. So loading, combining, like when you load different data sets from different sources, then you can combine, you can produce new tables, you cross matching, you can prepare. So a little bit of pre-processing, normalization, get rid of the non-numbers, all of that stuff. You can build your prediction models or whatever model, regression models, depending on what type of data analytics you might want to perform. You can manage that model either in a graphical or in a written way. You can take the decision then, like the flow. You can include other team members and share those with other colleagues or collaborators, and develop the whole code and flow in the same architecture, in the same platform. I think this is the best slide flip I could ever ask for, and it's available to all of you on the website. It just gives a great understanding of what this platform allowed you to do. But back on our slides, there are other areas where Intel and SAS collaborates. These are 3 macro areas, so AI, ML, and I know it's a buzzword, AI nowadays, but when we talk about ML, standard machine learning, so like standard statistics, regression system, as I was mentioning before, decision tree, all that stuff, but it's also on the deep learning side. And on the IoT, of course, there is more expertise and domain knowledge for each of the area the customers might need help with. And on the open source, the good thing is that the VIA integrates the open source technology, and including the Java, the Python, Golang, and the Python. It's what can easily explain or simplify my job in explaining the contribution that also Intel is providing to this amazing platform. It is not just an end product, it's a great collaboration and innovation through the co-engineering. So there are multiple tools used by SAS, tools that belongs to Intel, like the Parallel Studio XC, to basically it's a profiler. You can optimize performances based on that kind of thermometer. You can think of a profiler as the thermometer of your machine that allow you to see where the resources are being used efficiently and where are not, and so that you can optimize the usage of those. There are many other aspects like the mod kernel library, legacy's MKL, now rebranded as one MKL for the bigger efforts that Intel is going through with one API, but MKL is still the mod kernel library, which is the alternative to, let's say, the standard BLAST, like a linear algebra or this type of open source product. This is not open source MKL, but is absolutely free and publicly available. And the evolution of the MKL, which is the 1DNN for the deep learning part of the computation. And there is the storage, the AVX, which is the vectorization and advanced vector extensions. And we will see in a couple of foils, what do I mean by this, and why do they matter? They matter for the SAS acceleration. Having said that, Xeon processor is always the starting point for a lot of people. In this case with SAS, as I said, more than 20 years of collaboration, and now SAS VIA can be found hosted on the 3rd generation of Xeon CPU, which has a lot of let's say features and superpowers, but the 4th one, which is upcoming also for the SAS friends, has some more hidden gem that will hopefully speed up even further what's the current offer. And I would like to dedicate some time in explaining what's the upcoming, because upcoming doesn't mean that it's a future or is in the roadmap. It just means that this machine is shipping today. So it's just upcoming, the procedure to migrate also the SAS service on it, but the machine is already shipping today. So it's not really like tomorrow's future. It's something that's really out there delivering today. So I would like to take this 5 minutes to explain give you slightly a little bit more understanding of what are the AI superpowers and data analytics superpowers that Xeon itself brings to the table. Without further saying, let's kick off with that. It's going to be a little bit technical, but please raise your hand if you have any question, and I'll try to keep it as more understandable as I can possibly do. So when you deliver a computation to the Xeons, to the server, if it's for example, a matrix multiplication. Matrix multiplication is multiplication followed by addition, multiplication followed by addition. The same aspects comes to play when we talk about convolutional neural networks, so deep learning, which is a lot of multiplication followed by an addition. Now, the tricky thing is that if you would take a 10 years old machine from Intel and you would ask that machine to perform a matrix multiplication where the number are represented in int8, and you would like to add number in FP32, for example, that machine would take, if we go and zoom in what's going on at the computational level, you would realize that machine would take 3 clock cycles to complete that operation. That's due to an instruction set that was a little bit, let's say, good for that time, but not really optimal. That was taking the first cycle to do the multiplication between the two numbers and accumulating the result in a 16-bit. But then you would have the issue of adding a 16-bit number to a FP32-bit number. So in order to overcome that issue, there was just a silly step that was taken by multiplying this number by 1, represented in 16-bit, to accumulate the result in 32. Having the compatibility between the size of these two numbers, then we could perform the addition. Now, with the Xeon 3rd generation, which is already hosting SAS, this operation can be done in 1 clock cycle without you even realizing that. That just because we've added this VNNI, Vectorized Neural Network Instruction Set. Intel loves the acronym and loves to complicate life when it comes to remember the names. Again, if you have any question, please jump in. But so this is the major step that the 3rd generation provided. But guess what? In the 4th generation, we will not only be able to do this in 1 cycle, but we also can parallelize the computation. Why should you care about this, and why it's important for the ultimate data analytics and deep learning? Let's have a closer look about how this last option of parallelizing the instruction works. We've embedded in the hardware we've embedded 2 new components. One is hardware, one is software. The left, the tiles, a 2D register, and that's hardware. And the TMOL is basically a set of instructions to take advantage of this freshly added hardware. So this is a CPU. We're going to zoom in this blue part, and that accelerator is what is basically capturing this hidden superpower that we call AMX, Advanced Matrix Extension. The way it works is that you have the registers, so the tiles, so additional memory, simply additional memory available to each core. So when you have a matrix multiplication, which effectively is done row by column, and you sum them up, what we could now do is to parallelize that matrix multiplication by delivering the row by column multiplication to 1 core. And since that core has available more registry to store the information, that computation can be done in parallel. So 1 core, which is this, would take care of multiplying the TMM1 times TMM2 in order to get to the final result of TMM0. And to do this, you would need a component that tells you what operation needs to be performed on what data. The data are stored next to it with this 2 tiles register, and the information about what computation needs to be performed is given by the TMOL. The result of this is that with this simple instructions, which is the TMOL basically, you can do this operation super fast and in parallel, because instead of, you can basically deploy this 6 multiplication up to 6 different cores. And once each one has computed its own, let's say, row by column result, you basically have the result matrix out. And that can be done in 1 compute cycle. Any questions so far? Okay.
No questions in the chat or from the audience at the moment, but I'll let you know if I see anything. I keep an eye on it.
Okay, sounds great. Okay, so it's not over yet. The superpowers also including some more, let's say, community-driven effort. If you work in the domain of AI, specifically with deep learning, you know that the FP32 resolution might be too much, simply because it takes a lot to do the computation. Those are big numbers, and you don't really need that level of accuracy. So the community, namely Google, has introduced bfloat16 as a new format that only uses 16 bits. Now, somebody might argue, but Walter, legacy, we used to have the float, the FP16. So what's the point of introducing a new format when we already had something that used only 16 bits? Because the difference between bfloat16 and FP16 is that, as you can easily see from this image, the number of exponent bits reserved in the bfloat16 is exactly the same as the one reserved in FP32. And the number of exponent bit is basically the ability of a numeric format to represent a range of values. By shrinking that number of bits of the exponent, you will shrink the number of values that one can represent. Since we kept the same number of exponents, then we can represent the same range of value. It's just that each number has less digits after the comma. That's the only difference between FP32 and bfloat16. The same cannot be said for the FP16, because as you can see, it has a lower range of value and lower resolution for each of those numbers. No need to say, but it goes automatically that converting from FP32 to bfloat16 is a very silly operation. You just load the number, you truncate it, job done. In this case, it's a little bit more, let's say, it takes some more peculiar step and to convert the whole code. Those are just two of the biggest superpower that Intel has embedded in the Xeon 4th generation, codenamed Sapphire Rapid. You might have heard of it with that reference. There are some other superpowers that hopefully will benefit and will help SAS platform to be even faster and more efficient. Some example of additional accelerator is the in-memory analytics accelerator, the data streaming accelerator, dynamic load balancer, quick assist. I mean, it's a lot of stuff. I could go through all of this, but I would need one full day. It's just FYI, just to give you another perspective on the amount of efforts to optimize this device. Think of it that all this single accelerator I just mentioned to you used to be separate plug-in device. Like the QAT, its quick assist technology is great if you're working on encrypted data and you need to encrypt your data when moving that around. That is a device that used to be sold as an external plug-in card that would take the encryption offload from the CPU. You have now that in the CPU, but you're not using the CPU cores. You're using that accelerator, which has been resized to fit in the CPU. So all of those are embedded in this circuit, and it's available, as I say, it's shipping today. You also have the Compute Express Link, the CXL, to facilitate the data movement between memory and PCIe devices, for example, and many other aspect like increased bandwidth memory, DDR5, and a lot of great superpowers. With that said, the results we delivered so far is 2x accelerated completion of parallel analytics. This was SAS 9.4 on Xeon 81. The second number tells us the generation family. So this was already good, but we are the third generation currently hosting SAS today, and the fourth generation is the one which is upcoming. So we expect this number to get even better. A larger data set can be used, and more than 90% of SAS customers are currently hosted on Intel, which is extremely positive for us. With that said, the presentation is over, and let's see what question you might have for me.
Yeah, with the way we normally do this, people can raise their hands, put the question in the chat, or unmute themselves and ask a question live. At the moment, there are no questions, but Walter, I have a question for you.
Yeah.
Am I correct to say the way the workflow is, SAS Institute licenses special tools from you, which then they can use to monitor their own software and performance of their own software as they develop it, SAS 9, VIA, and the rest, to make sure that their own tooling is utilizing Intel chipset effectively. That's what this comes down to. Is that correct?
Yes, there are absolutely. There are, and actually there is an additional consideration. Yes, the first bit is exactly what you said. So yes, that's the answer to your question. Because of tools like Parallel Studio, which are free, publicly available, but that is, what gives you the perspective of how my application is using the hardware. So there is a reason why we give this session the name we gave. And this leads me to the other consideration. These are great features. We know how to use it because we are Intel, but we cannot expect all the end user to know how to use it. And very often we also need to educate them. So the SAS effort to take advantage of this feature and then provide a super high level and easily usable platform for the end user is just twice what it looks like. Because on one side, yes, the SAS VIA platform is simplifying life for MLOps operation, as I shown before by querying the website, but at the same time, it takes away all the efforts of making sure that the routine that are hosted within the platform are actually optimized on the optimal hardware. So it's a double effort from SAS, and so hopefully the customer will be able to see already a good, efficient use of the resources because SAS was already optimized to do this.
Makes sense. Makes sense. But does it also mean that when Intel is rolling out new features, like you mentioned, the parallel execution that's going to be coming out in the next generation? Imagine this, I have a customer that running SAS VIA in the cloud. Does it mean that by simply changing the generation of VM that we buy on Azure and moving it to the latest version of Intel, we could, in some cases, see dramatic boost in performance just by changing the hardware without necessarily reconfiguring SAS, without changing the software at all? Just is that possible? Is that how it can work sometimes?
Yes, the only thing that needs, of course, new hardware, the machine, the software doesn't know what the machine is able of. So the only one change eventually is to update the Intel libraries, like the 1DNN and MKL. But once that is done, no change, it should work out of the box. So if a customer legacy code was running on the current 3rd generation Xeon, and you would copy and paste that environment, you would add the latest Intel library, that code should still work out of the box. To be completely honest, even if you do a copy and paste from 3rd to 4th gen, it works out of the box. In that case, it might not be super optimal, but to make it optimal, you just need to install the latest Intel library, and that should give you the speed up out of the box.
Makes sense. Looking at the chat and questions, there's no more any other questions. Asking the audience. Yeah, go ahead.
I have one. Sorry. So what I mean, sorry, I joined a bit late in this, but yeah, I'm in the same phase of exploring the performance of the on-premise hardware versus the Google provided hardware. So how do we know that, like you mentioned, if they keep on upgrading the Intel libraries, we are going to get a similarly good performance. So how do you it's going to vary from virtual, the server is hosted on the virtual machines and versus the server which is hosted on the bare metals. Like how do we come to know like which version of the libraries, Intel libraries that we're using? Is there anything like we can get using some SAS automatic macro variables to pull this and compare?
Sorry, I missed one bit. The difference between the software in the virtual machine and the other was that bare metal.
Yeah, the bare metal solutions. Sometime it's not possible. In some cases, what happened was the solution which we have derived using the hypervisor was not sufficient, so we had to put back to bare metal solution and to use SST in some cases for the optimal performance. Let's say a more of SAS work and disk cache as a more critical thingy. So how do we measure? For example, you mentioned right one key point, like if we are using the Intel libraries, the more updated libraries, it going to offers very good performance than the before in the same hardware. So how do we know that what libraries it's been using? Is there any automatic macro variable available within SAS so that I can interact and fetch this information? Like we used to fetch the number of threads available and the number of CPUs available using some automatic macro variables.
Okay, that's great question, by the way. So for the last generation of Xeon, we are working on a version that can host that it's, let's say, more suitable for VMs, for VM hosting. So that means that the transparency between VM or bare metal should be, excuse me, the expected performances between VM and bare metal should be fairly aligned. Maybe, when you containerize or you go through a VM, there is a little bit minor drop, but that should be it. So that's the first bit of the answer. Then, how do you know whether the latest and greatest are enforced? Well, a good way is to start profiling the execution. Like with Parallel Studio, you can see if the resources or utilization is maxed and is maxed in the proper way. It's like, running an htop command just to see if the cores are actually fully utilized with multiple threads, or like that are basically stealing resources to each other, which is turning down into a worse performance, or if it's actually running smooth. If that's the first case, then you're good to go. If that's not the case, it might be due to several aspects. One thing that you can check is making sure that you have the latest version of MKL and 1DNN, specifically these two libraries from Intel. Okay. If you want to be 100% sure, you just download the latest OneAPI package, and that comes with the right optimization. In that case, you can trust that the computation it's delivered through the right kernel libraries. The way I'm saying is, unless you go and profile with dedicated example, the best way is trust that the latest Intel MKL library will give you that, because it's just a component. We didn't replace the whole library. We just added the instructions in case the machine is hosting a 4th gen Xeon processor. Then those will be the libraries leveraged during the mathematical computation, and you can trust that because those libraries knows how to interact with the AMAX features that I was talking about. Does that answer your point?
Yes, not fully, but yeah, I'm more because I'm in. Yes, please.
I can help with the last one. Walter doesn't get involved with the programming on SAS. So when you mention about macro variables, as far as I know, with my years of experience working on SAS doesn't track or expose the Intel properties or which libraries are used. And it's within the maintenance release notes of SAS that you can find the version of some of the libraries that have been incorporated when the software been shipped. But you can't find it through the macro variables.
Okay. Because normally as we install SAS, we go through that libraries and simply go through these libraries and we install. And I don't know, like, yes, if Intel keeps improving and we are not keeping this document up to date, like we have to use this library for the better efficiencies, then we will not use the full efficiencies, right?
I'm not entirely sure how it works, but perhaps Walter can suggest now. Walter, when SAS is producing the software, do we need to try and update can we be ahead of SAS on Intel libraries? Would that be beneficial?
I would expect that when SAS is porting and offering the latest offer on the latest Intel hardware. That part is already been done. It's already been validated. So you as a SAS user, you will already have an optimized environment for you to go and play with. So this should not be, this is part of the commitment, right? To work together. Otherwise, what was the point? Is, you know, the collaboration we have is really to validate the solution before it gets there. And this means that you will be able to leverage all of this without even realizing. So you will hopefully see just a difference, hopefully in a good way, of performances by transitioning from a 3rd gen based instance with SAS to a 4th gen based instance. That's it.
Yeah, you know, in typical SAS installation, what happens is, like, once you install during the fresh installation, if you did something, or if it during the migration from lift and shift, if you install the SAS, before installing SAS, you install the libraries. That's it. We are not you know, frequently touching this area. So
Okay.
It's lying static. Maybe it's very much possible during the SAS via 4 on the cloud, but in the SAS 9.4 parlance, it's really, I mean, less likely possible, I would say, in my perspective.
It's typical in the industry to not to update SAS 9.4 frequently, not even the latest maintenances that contain a lot of this type of changes or updates. But on VIA, to stay within a support, you need to update within 2 years, and that 2-year window is going to shrink a little bit. And with the VIA, updates are now available monthly, with long-term support updates available every 6 months, which likewise will contain, I would suppose, many of this type of changes.
Yeah, of course.
Another thing that you can try is, you know, simple computation, like with some matrix computation, right? Run it on the 3rd gen, run it on the 4th gen. 4th gen will be faster, you know, gen on gen is always faster, but it should be unreasonably faster. If it's unreasonably faster, it means that all the superpowers are at work. If it's just tiny faster, it means that we are using gen on gen. But if that's the case, please reach out and let's see what we could do to help you and SAS to get this performance out.
On that note, we're out of time. Walter, thank you very much for your time. Thank you for excellent presentation. Everyone, thank you for your questions. And there's no any other wrap up. Have a nice day, everyone.
Thank you. Thanks for the arrangement. It was helpful.
Thank you.
Bye.
Thank you.